All matter has an opposite called antimatter. All antimatter has the same mass as its counterpart, but opposite charge, which causes it to interact differently with magnets. For example, while an electron will spiral to the right when exposed to a magnetic field, its antimatter, a positron, will spiral to the left. You know, an electron and a positron have the same mass, but the electron has a negative charge, while the positron has a positive charge. It's so weird, right? I understand why you haven't heard about antimatter before. It's probably because antimatter is extremely rare in the universe, since a particle and an antiparticle annihilate into two photons when they touch. There isn't much of it around because it has already been destroyed. All this talk about antimatter started in 1928 when Paul Dirac came out with his famous Dirac equation, which described the electron. The equation implied that there had to be a particle just like the electron, with the same mass but with opposite charge. Interestingly enough, the man named Carl Anderson who first documented antimatter wasn't even looking for it. He was actually just studying cosmic rays, which are highly energized particles that crash into our atmosphere and give us information about space. He was studying these rays using a cloud chamber. A cloud chamber is basically a box filled with water vapor that wants to condense but doesn't have anything to form droplets around. When a charged particle, like a cosmic ray, enters it, the particle rips the electrons off of the water molecules, leaving ions. When that happens, it leaves a line of water droplets in the path of whatever entered the chamber so it can be photographed and observed. Anyway, when Carl Anderson observed the photo data that he recorded, he saw that half of the particles curved clockwise, while the other half curved counterclockwise. This let him know that they had opposite charges. This was unexpected because the particles that Anderson thought he would see were supposed to curve clockwise. He knew that he definitely hadn't just seen protons, since the data showed the thickness of the trails left behind all matched the size of the electron. Protons are much more massive than electrons, so there definitely wasn't any way that they could have entered the chamber. He knew that he had seen exact opposites of the same sized particle. He had found the first evidence of antimatter, the positron. What about the future? Scientists are looking for ways to harness the energy released in the reaction of matter and antimatter to make clean, efficient spacecraft fuel. Well, I hope that cleared up the confusion.